Today I will be solving the problem max water container. This problem kind of builds on our understanding of two pointers. So first let's understand the problem first before we even solve it. So we are given a input array heights which represents the height of our graph. So 1 is right here, 7 is right here, 2 is right here, and then so forth. Essentially what we have to do is we have to find an area between these two indices that would give us the most area for us to collect the most water when rain falls, right? So that's the problem. So what we can do is we can have our two pointers, because essentially what we have to do, we have to just calculate the area. And how we do that, we just do width times the height, and we can essentially just use two pointers. We can have left right here, we can have our right, we can have left here, we can have right here, a right pointer right here, and then we just compare our heights and say like whichever has the most height and the most width, like that would essentially has the largest amount of area, right? And then we just calculate it and we output our answer. So how we do it, right? So we have our left pointer and our right pointer. We have it at 0, and then we have our left our right at heights -1. Heights is just the name of our array, by the way. And then we have water, which is at 0, which will help us calculate the max amount of water that we have got, right? Because in some cases we like, let's say we calculate the water for from here to here, and it's something like 26. I don't know, it's an arbitrary number. And then we obviously say to ourselves, well, this is kind of a small height, this is a better one. And then we calculate our height for this, and this is our optimal solution. So we keep water at 0, and then return the max of water and the area to essentially, give it the best possible solution. So we say while L is smaller than R, sorry, our height is equals to min of height at L, comma, height at R. So why are we using the min function, right? Essentially, why are we using the min function? Because this is our bottleneck, if you think about it. Because no matter how tall the right side is or the left side is, if one side is short, then the water is just gonna spill over from here, right? Let's say we take two, like we have one our left pointer right here and right pointer right here. No matter how much water go, no matter how tall this is, however much water goes inside this container, it after this point is just gonna fall over, right? So we essentially just use the min to as our height. That's why. And then we have our width at r minus 1, r minus l, sorry, which is essentially our width for the whole area. So like from here to here, and then to calculate our area, we essentially just do uh, width times our height, or h in this case, and then now we say water is equals to max of water comma area. So this, because let's say we calculate the water for this area from here to here, it's obviously it's not the best case. So we move our left pointer from here, and then we calculate our water for this area. So we want to return the max, right? So that's what we're doing essentially. In the very first iteration, water is 0. The first area is obviously bigger, and in the second iteration, water is like 15. And if our area is bigger than 15, we want water to catch that value, right? And we can say if height at L is smaller than height at R, L plus equal 1, else R minus equal 1. Water. Right? So essentially that's what we're doing. We first calculate like the area, that way we know how much water we can have, and then now we can obviously see, well, this is not the most optimal solution, right? So we increment our left, and then we get our optimal solution, right? And we do the same for the left, I mean for our right. Let's say let's say like like the height of right was like right here, which is obviously smaller than our left. We increment our right variable. And this else block kind of handles the situation where like the height matches. Like for example, in this case, right? The height matches, that else block will literally like handle our when the height matches. Because when the height matches, it doesn't really matter which pointer we're incrementing or decrementing. So yeah, this should work. It did not, because I did not use heights. There we go. That should work now. Oh my goodness, my bad. Typos. This should. Oh my god, I'm so sorry, guys, but yeah, just make sure you're using the right names, no typos. Yeah, there you go. That worked. All right.